Voltage drop is one of those principles that we must understand to be successful in diagnosing any modern automotive electrical system fault. Let's have a look at a practical example of voltage drop, and one we often see in the workshop. We have one lead of a digital voltmeter connected to the battery negative post, and the other is attached to the alternator casing. With the engine running, the meter displays 1.2 volts. But how can that be? Both of my meter leads are attached to ground. This is a question we're often asked by techs all around the world, and the simple answer is voltage drop. Let's go back to some basics to help explain this electrical principle. Everything in an electrical circuit has some level of resistance. Apart from the load, the resistance value of the wiring, switch contacts, splice joints and fuses is rather insignificant. Another electrical principle we know is that current is a factor of the voltage applied against the resistance in the circuit. For a given source voltage, like that of the battery, high resistance components will flow less current than low resistance components. Here's a new electrical principle that we need to embrace. All available voltage will be consumed by the sources of resistance in the circuit, and the available voltage will be divided among the sources of resistance proportionally. Confused? Let's take a look at an example. Here is a simple circuit with a 12 ohm resistor connected in series. The resistor represents an electrical load. Think a simple light bulb. Voltage is needed to overcome the resistance of the load and force electrons through. If we were to measure the voltage on the positive side of the resistor, we would see a value equal to the source voltage of our circuit. Our new electrical principle states that all available voltage will be consumed by the resistance in the circuit. Let's move our meter lead to the negative side of the load. We can see a value of 0 volts. This shows that all the voltage was consumed, overcoming the value of the resistor. The amount of voltage that is dropped is the total of our source. That is, in its simplest form, what we mean when we talk about voltage drop. Let's see what happens when we add a second 12 ohm resistor in series to the circuit. According to the principles we've just seen, all the voltage will be consumed, although the voltage will be shared equally between the two resistors, because they are of the same value. By measuring voltage on the positive side of the first resistor, we will see the same value as the source voltage. When we move the lead to the ground side of the first resistor, the meter will display 6 volts, just as we would expect. If you have any doubts about what you've seen so far, we can prove it all using Ohm's law. Let's do a little math. In this circuit, we have a total resistance of 24 ohms, and our source is 12 volts. Using Ohm's law, we can calculate the expected current flow in the circuit, and this equates to half an amp. Now let's apply that result to one of the resistors in the circuit. Our answer is 6 volts, and that's exactly what our meter displayed. Remember that all the voltage will be consumed by each circuit resistance proportionally. If we continue to measure the voltage on the positive side of the second resistor, we'll see 6 volts displayed. This is because we've already dropped 6 volts across the first resistor. If we move the test lead to the ground side of the second resistor, we'll see that 100% of the source voltage has been consumed, as indicated by our meter reading. Earlier, I said that everything in an electrical circuit has some resistance, but the load is the primary source of resistance to be concerned with. If you perform these measurements on a working vehicle circuit, you'll notice there's a little less than source voltage before the load and a little bit of voltage after the load. Everything between the battery and the load, such as the wire, fuse and switch, are the cause for this difference. They each consume a very small share of the available voltage. And it's this real-world effect resistance has on voltage drop that makes it such a valuable tool when diagnosing electrical faults. Thanks for watching.